All right, this is 10.5 notes. This is scientific notation. So a number is written in scientific notation when it is represented as the product of a factor in a power of 10. So this factor, and I'm writing in white, that's not very helpful. This factor must be between 1 and 10. So it has to be greater than 1 and less than 10. And the power of 10 has an integer exponent. So this needs to be an integer, and this number needs to be between 1 and 10. Can't be more than 10 or less than 1. So I need to identify whether this number is written in scientific notation. So the two things I need to look for, this number needs to be between 1 and 10, so that's good, and this needs to be an integer, which is a positive or negative whole number. So yes, this is written in scientific notation. Letter B, this is an integer, but this number is less than 1, so no, this is not written in scientific notation because 0.9 is smaller than 1. So our second key idea is writing numbers in standard form. So the absolute value of the exponent indicates how many. So if the exponent is negative, we move the decimal point to the left, and if it's positive, we move the decimal point to the right. It'll make more sense once we see an example. Okay, so writing 3.22 times 10 to the negative fourth in standard form, the first thing I want you to do is write the number that's between 1 and 10. Okay, and then I see that it's times 10 to the negative 4. So I'm going to move the decimal 4 times, and since it's negative, I'm going to be moving the decimal point to the left. My number is going to be getting smaller. So move it once, move it twice, 3 times, 4 times. So my new decimal point is there, and I need to fill in zeros where there's no numbers. So this number in standard form, yes, you need to rewrite it. Do not give me a final answer with swoops, because it's hard to read. Ooh, whoa. So that is your final answer. Number B, letter B, 7.9 times 10 to the fifth. So this is a positive exponent, so I'm going to move it to the right 5 times. So 1, 2, 3, 4, 5, and add zeros. And my new number is 790000, and add your commas so it's easier to read. So 7.9 times 10 to the fifth is 790,000. So on your own, I want you to try 1 through 4, hit pause, and when you're ready to check your answers, go ahead and hit play. All right, number 1, this is not in scientific notation because, go back, 12 is not between 1 and 10. Therefore, this number is not written in scientific notation. The other thing, this has to be an integer, which it is, but since that is bigger than 10, it doesn't work. Write the number in standard form, 6 times 10 to the 7th. So I start with 6. Now, decimal point, even though you don't have to write it, it's the same thing as saying like 6.0. So my decimal point starts after the number, and since it's 10 to the 7th, we're going to move to the right since it's a positive number. 1, 2, 3, 4, 5, 6, 7. Add your zeros. And this turns into, rewrite it. And you get, wait, that's only 6. 1, 2, 3, 4, 5, 6, 7. Dang it. So you get 60 million. Is your answer to number 2. Number 3, 9.9 times 10 to the negative fifth. Since the exponent is negative, you're going to move to the left 5 places. 1, 2, 3, 4, 5. Add a decimal point, add in your zeros, and rewrite the answer. You get 0.000099. Number 4, 1.285 times 10 to the fourth. Since the exponent is positive, you're going to move to the right, starting at the decimal 1, 2, 3, 4. So this new number is 12850. So 12,850. So this one I once again failed at putting the picture in. So water is 1.0 times 10 to the third. Brick is 1.84 times 10 to the third. And apple is 6.41 times 10 to the second. So those are the 3 pieces of information that you need. So an object with a lesser density than water will float. An object with a greater density than water will sink. So use each density given, and I gave them to you in kilograms per cubic meter, to explain what happens when you place a brick and an apple in water. So what you need to do is you need to compare each of these densities by writing them in standard form. So water in standard form, 10 to the third. So I'm going to take 1.0, swoop to the right 3 times. 1, 2, 3. So water in standard form is 1,000, and that is kilograms? Yes. So that's kilograms per meters cubed. Brick, 1.84 times 10 to the third. You're going to swoop 3 times to the right as well. So 1, 2, 3. So this is now 1840 kilograms per meters cubed. And an apple, 6.41. I'm only swooping twice since it's 10 to the second to the right, and you get 641 kilograms per meters cubed. All right, so since the apple is less dense than water, the apple is going to float. And since the brick is more dense than water, the brick is going to sink. So that's the answer to example 3. So what if the density of lead is 1.14 times 10 to the 4th kilograms per cubic meter, what happens when you place lead in water? So 1.14 times 10 to the 4th, we need to put it in standard form. So you swoop 1, 2, 3, 4, and it's 1, 1, 4, add your zeros. So it is more dense than water by a lot. So lead is going to sink. And I just cut through that word. And I believe that is it for 10-5. See you tomorrow.